is Crib. I need you to pull out your notes for Chapter 9b and turn to 910, mass-to-mass conversions. We're going to go ahead and fill in our notes for this. You may have already been introduced to this, but we're going to make sure our notes are complete at this point. The first thing I want to do is write this stoichiometry pathway that you need to remember. We start with the moles of A, and we go to the moles of B, using the ratio, the molar ratio, which is always B over A. And you should have already gotten this part. We've used it already some. Now, if I don't have moles, if I just know the grams, that's the mass of A. So the mass of A can turn into the moles of A using the molar mass of molecule A. And the moles of B can turn into the mass of B using the molar mass of B. So mass of B, molar mass of B. Now, what if I don't know the mass? Maybe I know the number of particles of A. The particle count, which are atoms and molecules, can turn into the moles of A. So if I know the particles of A, I can turn to moles of A using Avogadro's number. And if I want to turn the moles of B into particles of B, I can turn it into particles of B, again using Avogadro's number. Remember that A is the thing that I know, and B is the thing that I have a question about. So wherever the question is, that's the B molecule. And you need to be able to follow this ratio each time. Now we're going to be adding a couple more little pathway spokes to this, but this is the main thing. So let's read this. What is the mass of water? What is the mass of water? So what is the mass of water? That's the question. Now, mass is grams. Mass is always in grams, okay? So what is the mass of water? That means here. The question is here, and we're asking how many grams. You should always put the unit there. We'll react with 3,550 grams of diphosphorus pentoxide. So we have 3,550 grams. Now notice how I write the information in the word equation down below the balanced equation. Remember, in order for this to work, the equation has to be balanced. And in this case, it is a balanced equation. Now, I'm going to make you check that most of the time, or maybe I'll tell you to balance it, but you need to make sure you have a balanced equation. All right, so now I'm going to label these as A and B, okay? The thing that I know is this thing. I know the molecule, and I know how much I have. So that's molecule A. And the question mark is always molecule B. So this is molecule A, and I have grams. That means I am starting right here with the mass of molecule A. And so in order to get to, it's asking for grams, that's the mass, I have to get all the way down to this other end of my pathway. So I've got to go through all of these steps to get there, okay? So we're going to use the pathway to help us remember what to do. We're changing mass into moles. So we're going to find the molar mass of A. That's our first step. Now you always begin with the number inside the equation. You don't begin with a conversion factor. You begin with the number you were given in the equation. So 3,550 grams of diphosphorus pentoxide is my beginning point. Now, to go from mass of A to moles of A, I need to use the molar mass of molecule A. So I'm putting the conversion factor use down here. That means I need the molar mass of this molecule. Now I'm going to calculate the molar mass of this molecule off to the side. I normally do it right below it, but I just don't want to be cramped in my writing. So diphosphorus pentoxide, I need to know what is the molar mass. So I list the atoms, and there are 2 phosphoruses and 5 oxygens. And phosphorus is 30.97. I get that off the periodic chart, 2 decimal places. Oxygen is 16 off the periodic chart, round it to 2 decimal places. And then I need to multiply it through and add it together. So I'm going to pause the video, multiply it through, and put it on there for you. I put it on there for you, but I didn't do it perfectly. One thing I want you to remember is if there's 2 decimal places here, you need the 2 decimal places still there. And then 5 times 16 is 80, and I see a lot of people doing that. That is not correct. It's 80.00. You have to have the significant figures there. Now you add it together. Now you notice how I did the multiplication first, and then I added. It's a common error to forget to multiply it before you add it. So you don't want to do that, because you can still do percent composition and things if you have this all set up. So this is 141.94, two significant figures all the way down, grams per mole. You must write the units. This is also another error that happens a lot. So this is the molar mass of molecule A, and it's what I need here. And what am I trying to do? I am trying to convert grams into moles. And so moles is what I want. So I need the 1 mole to be on the top. So the conversion factor I'm going to use is not this one. I'm going to use 1 mole over 141.94 grams. So I put 1 mole on top over 141.94 grams. And now I can cancel out the grams and the grams. And I have moles of diphosphorus pentoxide. So I just got to here, moles of the first molecule. Molecule A, I know what it is. Now I need to go to molecule B. How do I get there? I use the ratio. So my next step is going to use the ratio, and the ratio is always B over A. So what's molecule B? This one right here. And the ratio, you use the coefficients. This is where you use the coefficient of 1 or 3. Notice the coefficients are not used for the molar mass, because the molar mass is how many grams are in 1 mole. So I need to use the coefficients, and I need to use molecule B on top of molecule A. So 3 moles of water over 1 mole of diphosphorus pentoxide. Okay? So that's the ratio, and we can cancel out units again. Now I can cancel diphosphorus pentoxide. I can cancel out 1 mole, and if I stopped my math, I would know the number of moles of water. I just changed molecules. But that is not the question. The question now, we just got to here where molecule B is water. I know how many moles of B it is, but it wants to go to mass, so I need the molar mass of B. Now I need to use the molar mass of molecule B. Well, I'm going to calculate that over here. So this was the molar mass of A, and so I have water, and I need, that's the molar mass of B. So there's hydrogen and oxygen, 2 atoms of hydrogen, 1 of oxygen. That's going to be 2.02. 16 for water, oxygen, 1.01 for hydrogen, 1.01. So 16.00, add it together, 18.02 grams per mole. That, with the correct unit, is the molar mass of molecule B. Okay, so that's what I need to use next. Notice that there are 3 oxygen moles in the recipe, or in the balanced equation, but over here I only used 1, and that's because molar mass is the grams in 1 mole, not the grams in 3 moles. So now I do that, I got to put it in a way that the moles will cancel, and already that's the way. So 18.02 grams in 1 mole. Now I can cancel that unit. Moles cancel with moles, and now I have the math all the way set up. The things that didn't cancel are water and grams. So grams of water will be my unit at the end, and I just have to do the math. Now I'm going to pull up my calculator this time so you can watch me, because I want you to just go through from left to right. Okay, we start off, we have 3,550, and since 141 is at the bottom, we divide 141.94, and since 3 is at the top, I'm going to multiply times 3, and since 18.02 is at the top, I'm also going to multiply by 18.02, and I get 1,352.07. 1,352.07. Now I'm almost done. Sig figs, guys. Sig figs come from the first number. That's the only number that was in the problem. It's the measured value. This one the decimal place is absent, so we come in from the Atlantic. It only has 1, 2, 3 sig figs. So I need 1, 2, 3 sig figs. I need to round to that position. 1,350. The 5 has to stay in the tens place. We put a 0 where the 2 is, so that 5 is still at 50, not at 5. 1,350 grams of water. As long as I didn't do anything in my math wrong, that's the correct answer. That's the 100% answer. And use the pathway. Okay, let's move on down. Here, I wrote out the pathway for you in a little bit of a typed fashion, but I want you to be able to recognize it. And so the moles of B, mass of B, moles of A, mass of A. Particles, you use Avogadro's number. Particles, you use Avogadro's number. To go from mass to moles, you use the molar mass of A. To go from moles to mass, you need the molar mass of B. Now, I prefer my handwritten version, so I'm going to stop here and write my handwritten version out. Write out my handwritten version so that I can follow along, and we're going to look at this right here. For how many grams of sodium chloride? Well, I didn't give you the formula, so you got to figure out what the molecule is. So sodium is Na, chlorine is Cl. Sodium is a +1 charge, chlorine is a -1. Swap and drop already, or they already cancel each other out. So that's sodium chloride. Remember, you can use your oxidation chart and you can use your polyatomic ion chart. So how many grams of this decompose? When you decompose, you fall apart to yield 27 grams of chlorine gas. So we have to write out the balanced equation first. We don't even have an equation, and we have to write it. So sodium chloride, and we're going to decompose. That means fall apart. We have one thing over here. It's going to fall apart into its pieces. It's going to fall apart into sodium and chlorine. But this is where you have to remember something about chlorine. Since chlorine's by itself, remember diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So when they're by themselves, it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine or iodine. Okay, so I have chlorine in this, so it's going to have the 2. If I don't put that there, I am not going to be able to balance this equation. I will not be able to do this question correctly. When it's by itself, remember, these are the diatomic elements. This is all the way back from chapters 2 and I don't know, somewhere around there. 2, 3, 4. All right, now we got to balance this equation. It's not balanced. So I'm going to list the elements. Sodium and chlorine, 1 and 1. 1 goes to 1 and 1 goes to 2, so that's not balanced. So I put coefficients in front to get the chlorines. Now 2, we have 2 sodiums, and 2, we have 2 chlorines. And I just have to put a 2 here, and now with the balanced equation, we're good. Once it's balanced, we can do the math. We can do the work. So how many grams? I'm going to rewrite the equation over here so I can write the stuff in my question underneath my balanced equation, which is a very good practice. Please don't think this is a waste of time. This is not busy work. This is keeping your details and keeping your logic in order. How many grams of sodium chloride? That's the question. The question is how many grams. Decompose to yield 27 grams of chlorine gas. 27 grams. So now I'm going to hunt molecule A and B. The thing that I know is molecule A. The thing that I want to know about, the unknown, the question, is molecule B. So where am I starting? I have grams of A. That means I'm starting here at the mass. Mass is in grams. And I want to know grams of B, so I'm going to go all the way down to here. So this is another mass to mass equation. That's what we call them, going from mass to mass. To go from mass of A to moles of A, I need the molar mass. You start with a number inside the question. You don't start with a conversion factor. So 27 grams of sodium, no, 27 grams of chlorine. Let me erase that real quick. There you go, for 27 grams of chlorine gas, Cl2. It's important that you write the 2 there because that is what the molecule is, Cl2. All right, the first thing I need is a molar mass of A. Well, this one's easy. It's only 2 atoms of the same molecule. So we have chlorine, we have 2 atoms of it right there. Notice there are 2 atoms in the molecule. So we have to have the 2 here times the molar mass, which is 35.45. So that gives me, what is that? Let me put that real quick. 35.45 times 2, 70.90. So 70.90 0.90 grams per mole. That's the molar mass of A. All right, I need the grams to cancel. So I don't need it. If I wrote 70.90 grams in 1 mole, and you don't put both the units on the top. This line is the line right here. Okay? If I did this, what I should notice right away is that grams and grams are not canceling. So that's a clue. I did it. I've got it upside down. So I need to turn my numbers upside down. I got the conversion factor upside down. So it's going to be 1 mole over 70.90 grams. Now I can cancel out the unit. And I just finished going from here to here. I now have the moles of molecule A. Molecule A was chlorine. I know how many moles there are. Now to go to the moles of A to the moles of B, I have to use the ratio B over A. So I'm going to use the ratio next, which is B over A. B is right here. This is molecule B. And I have 2 of them. The only place you use the coefficients is in the ratio. The only place you use the coefficients is in the ratio. So B goes over A. So 2 moles of sodium chloride, and then A over 1 mole of chlorine gas. All right, so I can cancel units again. I now can cancel chlorine and moles. And now I have moles of sodium chloride. So where am I now? I'm here. I'm now at moles of B because B was sodium chloride. To go from B to mass of B, I need the molar mass of B. So that's the next step. I need the molar mass of B. Now notice how I'm writing underneath each place what conversion factor I need to make this work. I need the molar mass of B, so I need the molar mass of sodium chloride. So there's only 1 atom of each. Chlorine, 1 single atom is 35.45. Sodium, 1 is 22.99. And then I'm going to just add it together. Since there's only 1 of each, I just have to add it together. I don't have to multiply. So 22.99 plus 35.45, I get 58.44 grams per mole. This is the unit. You must put the unit. If you don't put the unit, you lose 1/4 of a point, and that's the molar mass of molecule B. Now, I have to use it in this spot, and I want to use it so the moles will cancel what's already written the correct way. 58.44 grams. This line is this line in 1 mole. So we cancel out the units, 1 mole and 1 mole. And now we just do the math real quick and we'll get our number. Okay, I did it, and I have 44.510, but I got to look at significant figures. There are 2 significant figures in this number. This is the number that was inside. It's the measured value. These are definitions. So I need 2 sig figs. So I'm going to look at the 5. It causes my 4 to round up to 45. Sodium chloride didn't get canceled, and neither did grams. So it's grams of sodium chloride. And that's the correct answer. That's the 100% answer. Okay, I hope you got that one. Let's move on. Now I'm just going to introduce you to the idea of a limiting reactant. Honors are the only ones who are going to have to do all the math with limiting reactants, but everybody needs to understand the concept. A limiting reactant, the reactant that gets used up before the other reactants and thus determines how much product you can produce. So if we look at our recipe at the beginning, it says if I had all the ingredients or reactants but only 1/2 cup of powdered sugar, you could still make the bars, but how much? Well, if you go back to the very beginning of your notes for chapter 9b, all the way back when we talked about this, if I only had 1/2 cup, see, powdered sugar I should have had a cup, but if I only had 1/2 cup, that's 1/2 this amount. That means I can only make 6 cream cheese bars because once I use the 1/2 cup up, I'm done. So that 1/2 cup of powdered sugar is the limiting reactant. This 1/2 cup. The powdered sugar limits this reaction. It keeps us from making more than 6 cream cheese bars. It gets used up and there's nothing left of it. Even if I have lots of these other things, there's no more powdered sugar left. I cannot make any more cream cheese bars. So that's the limiting reactant. It stops the reaction from going forward. So I could make, it says how much? I could make 6. Would you have any ingredients left over? Well, you might. You might have some of the other stuff left over, but you would have no more powdered sugar left over. Okay, I'm going to pull up the Prezi for just a moment and then move on from there. I pulled up the Prezi and the video I was hoping was there is not there, so I will do it separately on a different Edpuzzle, just a short video that just another way of thinking about limiting reactants to help you to just understand the concept. Okay, so this is where we're going to stop. You're going to be given extra problems to do at this point, and those problems are going to go along the same method as was in this. So I hope you can do that. I'll see you soon.